In Switzerland, we have since the end of the 19th century built lines to transport electricity. Electricity flows in more than 6,700 kilometers of lines, with more than 12,000 pylons to arrive in all houses, apartments and businesses. We will introduce the basics of electricity through the transmission of electricity. The video is divided into 5 parts. Here are the different parts of our presentation: network presentation, power and loss of power, insulators and drivers, the series and parallel circuit, security and interconnection.
The voltage is transported for the most part time in alternative because production factory produce AC voltage. It is transported in continuous voltage for very special cases, as for certain submarine cables for example. I talk briefly about alternative voltage so you have an idea of what AC voltage is. These two graphs show once the DC voltage and once the AC voltage. We have on the x-axis the time in seconds and on the y-axis the value of the voltage for the moment t. For the DC voltage, we see that the value of the voltage remains the same in the time. That's why we call it that. On the contrary, for the AC voltage, that the value of the voltage takes in time the shape of a sinus.
The electric network is divided into 4 parts. The first part has a voltage of 380 kV or 220 kV. The second has a voltage of 36 kV to 150 kV. The third has a voltage of 1 kV to 36 kV. And finally, the last part has a voltage of less than 1 kV.
What's the point of using high voltage on electric pylon? There is 2 reasons: the need of a stable energy supply and to avoid energy loss. So, if you want to power houses in a big energy network, you need to have a constant tension. And to keep it constant, you have to avoid the drop in supply voltage. You don't want to be short of voltage or the forest receiver won't work. Neither did you want to be over high in voltage or it will be dangerous and potentially damaging to the closer receiver. You just want to be a little higher than the need, so if there is a little drop, it will compensate. The second reason is about loss of energy. When you power something with energy, it will heat because of the Joule effect. P equals the square of I times R. And you want to avoid this by reducing the power in the cable. Because the formula of the power is P equal U times I, if you want to keep the same power, you will have to increase U proportionally as you lower the I. And the only way you can make this is by increasing the resistance on the cable. You may know that when you use cables to conduct electricity, if it's not a superconductor, the cable will resist, like a classic resistance. And trying to reduce the resistance will lead to a heavier and much more expensive cable with better material or cable too tiny that will melt. So instead, why don't we just increase the resistance by making bigger cables so we can increase the tension? Let me explain. You want to reduce the power so it won't heat and lose electricity. But at the same time, you want to keep the same amount of power every second. So the best way to do that is by giving a bigger path to the electricity. You can make an example with the water pipe. If you want to keep the same water flow, you increase the width of the pipe and proportionally lower the pressure. So we can take the base formula of the tension or voltage. So the base formula of the tension or voltage is resistance times the current, U equal R times I. The loss is the resistance times the square of the current, P equal R times I times I. The power is also tension times the current. You can see that if you lower the current, it will have a bigger impact than if you could reduce the resistance.
To start, we need to differentiate the parts of a high voltage line between insulating and conductive materials. As a reminder, a material is said to be insulating when it totally prevents the passage of current or when it resists the passage of electrons. A conductor, meanwhile, is a material allowing the passage of electric current. They are used to allow the current to circulate. The part that is conducting in a power line is obviously the cable. It was formerly copper and is now increasingly replaced by aluminum alloy. Aluminum has replaced copper for several reasons. Although copper conducts electricity twice as much, its cost is about 3 times cheaper and its density is also 3 times lower, which allows lighten the high voltage lines. Let us recall the formula. Resistance equals resistivity times length divided by area, which makes it possible to define the resistance of an element according to the resistivity of the material, its length, and its surface. The longer a cable is, the more the resistance of the wire increases. So we must find a material with a very low resistivity and a density not too large to increase its section and thus reduce its resistance. By taking aluminum, it is enough to braid a multitude of wires to thus obtain a larger surface and thus to reduce its resistance. Especially since aluminum is not corroded by water and avoids problems on the lines. As for insulating materials, we have parts called insulators. These prevent the current from passing from the cable to the ground via the pylon. These parts are attached to the electrical pylon and support the cables. They are made of glass, ceramic, or synthetic materials, all of which are very good insulators. The material of the electric pylon is generally steel. It is placed high enough to ensure safety and isolation to the earth. Of course, the biggest drawback of overhead electrical installation is their exposure to the weather, snow, storms, lightning, etc.
I will show you how electricity is distributed in our house. Here is a series circuit. Imagine that a resistance represents a house. Each resistance is 10 ohm. The tension of our network is 230 volts. To calculate the equivalent resistance, we add the resistance to obtain a result of 30 ohm. Then, to calculate the total current, we will use the Ohm law and we transform it to find the total current. I equal tension divided by equivalent resistance equal 230 divided by 30 equal 7.67 ampere. The current remains the same in all the series circuits. Now we can use the Ohm law to get the voltage. Tension equals the first resistance multiplied by ampere, equals 76.7 volts. Here is the voltage of the first resistance, and we will do the same for the other two. We also find 76.7 volts. We see that the voltage is below 230 volts and that our device do not work. Now I am going to show you the parallel circuit. It's known that the voltage remains constant in parallel, but the current changes. To calculate the equivalent resistance, we use the calculation. To know the total current, we will divide the voltage by the equivalent resistance. So we get 23 amperes for the total current, which gives us 7.7 amperes per resistance. Now that we have seen the operation of the series and parallel circuits, we can deduce that our houses are connected in parallel, because the voltage never changes. Then, if a house had a problem, all other houses will no longer be powered. This is the advantage of the parallel. If a house has a problem, the other will always be supplied with electricity.
The vast majority of high voltage lines are aerial. There are several reasons for this choice. The line in height reduces enormously, nay, completely the risk of contact with a person. This contact is very likely to be fatal for this person. The hair also isolates the line between them, and thus prevents arc and short circuit from forming between the lines. The hair is a very good insulator. This makes it possible not to put an insulating sheet on the cable. This reduces the costs and weight of the lines. The laying of underground lines is more complicated and more expensive. In addition, underground cables must be properly insulated to avoid short circuits, thus who costs more. During the passage of great currents, there are losses in heat. To explain this to you, I will tell you about these two formulas. P equal R times E squared, formula developed by Gabriel. R2 equal R1 plus R1 times delta temperature. When the temperature increases, the resistance of the line will increase. As the resistance increases, line losses will also increase. Conversely, if the temperature drops, the resistance will drop and therefore the line losses will drop. The advantage of overall line is that the heat is dissipated in the atmosphere and the resistance of the line will not increase or that very little. In winter, thanks to the lower temperatures, it is therefore possible to carry much more power than in summer.
The video is now finished. Thank you for watching our video. We hope this video could help you better understand the basics of electricity.